Remember, to iterate over a sequence is to execute some block of code individually for each item in that sequence. So iterating over a list means executing a segment of code for each individual item in the list. The same can be done for a tuple as long as we're not trying to modify it. So recall that earlier when we talked about loops, we had a program where the user would enter a bunch of grades, and it would just average those grades together. Now let's revise that program to instead average the numbers in a list. In fact, let's make it a function so that it could be used in other ways by a hypothetical program. So here we define a function called average, which will take as input a list of numbers. Down in our main code, we define two lists. We then call the function average with the first list and then with a second list, printing the results of each execution. When we call average from mylist1, this list of numbers becomes mylist. Then we create a variable named sum and set it equal to 0. And then for each item in this list, we set the variable number equal to that item and then run the indented code, which just adds that number to sum. And then at the end, we return that sum divided by the number of items in that list, or the length of that list. So we've seen this before, but this is the first time we've seen it since actually covering what lists really are. So a for loop that iterates over each item in a list will execute the indented code once for every item in that list. Each time it does, it takes the next item, sets it equal to that variable, and then runs the indented code. Generally, when we're dealing with lists, we use for loops like I've shown here. When we covered loops, we said that anything you can do with a for loop, you can also do with a while loop, and that's still true. We technically could use while loops here, but for loop just tends to make it a little bit easier. It's easy to think about, do this for each item in the list. It's a little bit harder to think about, do this until I've done it for every item in the list. They're functionally the same, it's just a little bit more natural to think about this for each approach. The constraint on for loops was that we needed to know the number of times the loop should iterate in advance. But if we're giving it a list, then the length of that list tells us at the very beginning how many times the loop needs to run. So we don't need to worry about keeping track or manually finding how many times we need the loop to run. It'll automatically run for each item. The only caveat is that we can't modify the length of the list while running the loop, or else things start to behave a little unpredictably.